Ladies and gentlemen, welcome to Elimu 24 TV. I'm your presenter, Wawire Christopher, and today we are taking a lesson in chemistry Form 2, and this is a very interesting lesson in alkali metals. So before we continue, I want us basically to know the objectives of the lesson. By the end of this lesson, you should be able to do the following. First of all, you should be able to identify the alkali metals and write their electron arrangement. And then, number two, you should be able to explain the trends in the property of the alkali metals. You should be able to explain the trends in the properties of the alkali metals. And then you'll be capturing these things as you go throughout the lesson. So we want to start immediately. What are these alkali metals? So alkali metals, these are metals that belongs to group 1 in the periodic table. They belong to group 1 in the periodic table. And you knew that group 1 elements, these are elements that has one electron in their outermost energy level. Examples of alkali metals are, we have the lithium, we have the sodium, and we have the potassium. So if I just maybe draw the electron arrangement in these alkali metals, they will be as follows. Number 1, lithium. Lithium has an atomic number of 3. Lithium has an atomic number of 3. And then we have the potassium. Potassium has atomic number 19. We have sodium. Sodium which has the atomic number of 11. So we have sodium, atomic number 11. We have potassium with atomic number 19. So if you check the electron arrangement of these elements, lithium, the first energy level will take a maximum of 2 electrons. So we'll have 2 to 1. And then 1 electron goes to the second energy level. And then 1 electron goes to the second energy level. Let's go to sodium. Sodium has an electronic arrangement of 2 to 8 to 1. In other words, the first energy level will take 2 electrons. The second energy level takes 8 electrons. And the third energy level takes 1 electrons. 2 to 8 to 1. So we have 2 to 8 to 1. Let's check the electron arrangement in potassium. Potassium has an atomic number of 19. The first energy level takes 2 electrons. Okay. The second energy level takes 8 electrons. And then the third energy level takes, again, 8 electrons. The fourth energy level will take 1 electron. So you'll have 2 to 8 to 8 to 1. So what can you ascertain from all this? We realize that all these metals, they have 1 electron in their outermost energy level. There's a common trend in that all these metals have 1 electron in their outermost energy level. 1 electron in the outermost energy level in lithium, 1 electron in the outermost energy level of sodium, 1 electron in the outermost energy level of potassium. So the alkali metals, they belong to group 1, and they have 1 electron in their outermost energy level. So that's the general trend in all these alkali metals. So I just want to show you the periodic table. On your screen, a periodic table will be appearing, and basically the periodic table will show all the elements that we are talking about in the alkali metals. So the first in group 1 alkali metals, we have hydrogen, and then we have lithium, we have sodium, we have potassium, we have rubidium, we have cesium, and then we have francium. So all these metals have one electron in their outermost energy level. That's a general trend, that they have one electron in their outermost energy level. So we continue with our presentation. So there's a general trend also that the atomic radii of alkali metals increases down the group. Why do we have the atomic radii of alkali metals increasing down the group? One is because of the increase of the atomic number. It's because of the increase of the atomic number. And then two is because of the increase in the number of energy levels. So as you can see from the electron arrangement here, the first atom is the lithium. Lithium has atomic number 3. And if you check the electron arrangement in lithium, you'll see that lithium has 2 energy levels. Lithium has 2 energy levels. And then looking at sodium, sodium has 3 energy levels. Sodium has 3 energy levels. And then potassium has 4 energy levels. So that's number 1. And then the increase of the atomic number. That's number 2. So we have 2 reasons why the atomic radii increases down the group. So moving on, there's a demonstration, or rather we have some models there showing on your screen how the atomic radii increases down the group. You can see that hydrogen is smaller, lithium is bigger, sodium is bigger than lithium, potassium is bigger than sodium, and so on and so forth. So the atomic radii increases down the group according to the model you're seeing on your screen now. So we move on to ionization energy. What is the ionization energy? Is the minimum amount of energy needed to remove the outermost electrons from an atom in a gaseous state. So that is the ionization energy. So what is a general trend in the ionization energy in the alkali metals? What is the general trend in the ionization energy in the alkali metals? The ionization energy basically decreases down the group. So if you check, sodium, or rather lithium, has less ionization, or rather has more ionization energy than sodium, and then than potassium. So lithium has more ionization energy as compared to sodium, as compared to potassium. So we have the ionization energy decreasing down the group. So let's move on to another thing, that is the chemical properties of alkali metals. So we have an example, the reaction of sodium with water. What normally happens when you react sodium with water? Sodium reacts with water to form hydrogen gas, and sodium hydroxide solution is normally formed. And how is the reaction? The reaction takes place vigorously. That reaction is vigorously. When you compare this to the reaction between water and potassium, potassium reacts more vigorously with water than sodium. Why? This is because there's a general trend in that the reactivity of these alkali metals normally increases down the group. There's a general trend in that the reactivity of alkali metals basically increases down the group. Let me explain that. Looking at this electron arrangement in lithium, sodium, and potassium, you can see that lithium has 2 energy levels. Sodium has 3 energy levels. And then we have potassium having 4 energy levels. So there's the ease of losing electrons. Potassium easily loses electrons than, let's say, lithium. Okay? That ease of losing electrons, because you already know that metal normally reacts, all the metals actually, normally reacts by losing electrons. all the metals normally react by losing electrons. So there's an ease in losing electrons in potassium than we have in lithium. That is an equation showing the reaction between sodium and water. So when sodium reacts with water, it forms sodium hydroxide plus hydrogen gas. Chemical symbol of sodium is Na there, and then it's a solid. If you add water to this, the chemical symbol for water is H2O. You already know that, okay? And then water is a liquid, a small l, and then we'll form sodium hydroxide plus hydrogen gas. Put an arrow there. Sodium hydroxide, Na, plus hydrogen gas. Okay, so sodium plus water, we have sodium hydroxide plus hydrogen gas. So the reaction between potassium and water is also the same thing. Potassium, chemical symbol for potassium is K. It's a solid plus water. Water is a liquid. We have potassium hydroxide plus water plus hydrogen gas. Sorry. So in a nutshell, today what we have discussed is the alkali metals. Examples of alkali metals: we have lithium, we have sodium, we have potassium, and then we have seen the trends in properties of the alkali metals. First, the trends in the physical properties, in that the atomic radii increases down the group, and then a trend in chemical properties, that is the reactivity of alkali metals increasing down the group. We have also checked the ionization energy, which decreases down the group. So at that point, I want to wish you well until the next presentation. For more information on this video, just go to the web portal, which is www.nfschools.co.ke, or you can ask a question using your mobile phone, and you'll get a response from a teacher who is standby. Thank you, and let's meet in the next presentation.